Good morning, everyone. My name is Steve Mykytyn, and I'm the Corporate Technical Trainer here at AprilAire. And this morning we're doing a NATE class on evaporative humidifiers. Winter's come early, at least up here in Wisconsin. We've had a span of bitter cold, so lots of furnace no heat calls and those kinds of things. Hopefully that bodes well for the rest of the heating season. I'm going to go ahead and get started. As usual, we've got a lot of people attending, which I really appreciate you taking the time. However, it does mean that I'm not going to be able to get to all of your questions. Just as a accounting note, if you attended our previous webinar on steam humidifiers, we had so many questions. I'm still working through those, so it's great that we're getting all this attendance, and I appreciate your patience as I catch up and answer all your questions. So let's go ahead and get started this morning. It's a NATE class, so we want to do a little bit of background information, kind of explaining humidity and all that kind of stuff. So let's start with how humidifiers work. It's very basic. You need three things in the right ratios to get good evaporation: heat, water, and airflow. That gives us good evaporation. It lets us raise the humidity inside the home. I know it seems oversimplified, but it's really not. If you've got an application and you're wondering, can I install it like this or like this, keep those three things in mind. Where am I going to get the heat from? Obviously water. And then am I going to have sufficient airflow for this application? That'll help you decide if an install is a good choice. It'll also help you when it comes to if you call in with any troubleshooting questions. The questions are basically going to revolve around making sure we've got the right amount of heat, the right amount of water, and the right amount of airflow. If we do, we should be getting proper humidification being produced by the humidifier. We're going to be talking about our evaporative humidifiers today. The key thing about an evaporative humidifier is the humidity that's being introduced into the ductwork is a gas. The water leaves the water panel as a gas. So it's not spraying out a fog or a mist. So we don't have to worry about rusting or water damage, anything like that, because the moisture is already a gas. Water vapor is going to pass through filters and blowers and everything else, just like the oxygen in the air passes through the filter and the blower. The only thing that's going to turn that water vapor back into a liquid is coming in contact with a cold surface, like your windows. So that's a huge advantage over, let's say, a drum humidifier with a big tank of standing water, or an ultrasonic humidifier, or a spray humidifier, anything like that. I want to talk a little bit about some terms so we know what we're talking about here. When we're talking about humidity, we're primarily talking about relative humidity, talking about how much moisture the air can hold talking about how much moisture is in the air compared to how much moisture the air can hold. And the reason we have to add humidity into the home during the heating season isn't because the air outside is dry, it's because when that air leaks into the home, or we mechanically bring it into the home, we need to heat it so it's a comfortable temperature. And when you heat the air, you increase its ability to hold moisture. And if you don't add any humidity, the relative humidity drops. You've got a couple cylinders here to illustrate this. In the first scenario, the air temperature is 30 degrees and there's 12 grains of moisture in the air. That's how we measure absolute humidity. So this is typical outside day for much of the country during the heating season. The height of the cylinder represents how much moisture the air can hold. So at 30 degrees, the air can't hold a lot of moisture, so that cylinder is relatively short. The amount that the cylinder is filled is represents how much moisture is actually in the air. And the ratio there, you can see that cylinder is about half full, so the relative humidity is 50%. It's halfway towards being saturated with moisture. As that air leaks into the home, of course, the furnace, heat pump, radiant heat, whatever you've got, heats the air up. In this example, it heats up to 70 degrees to make it more comfortable. That increases the ability of the air to hold moisture, so the cylinder gets taller in our analogy, but we haven't added any moisture yet. So there's the same amount of moisture in both diagrams, but because the air can hold so much more moisture, the cylinder is a lot less filled. So the relative humidity is only 12%. So it's the change in temperature. It doesn't matter how we change the temperature, it's the change in temperature that lowers the relative humidity. Well, so what do we do? Oops. So what do we do? Well, what we need to do, now that we've heated the air up to 70 degrees, so the temperature is comfortable, but the relative humidity is too low. The relative humidity is bad for people, bad for your wood floors, etc. So what we need to do is we need to add absolute humidity. We need to add moisture to the air to increase the relative humidity. So you can see in our example here, we add 52 grains of moisture per pound of dry air. That gets our relative humidity back up to 50%. And that's what an AprilAire humidifier does. Okay, I'm going to show you this calculation, walk you through it, and I'm going to show you we've already done all the hard work for you because we have a table. But this is the actual psychrometric calculations that you go through. Let's say you've got a 2,000 square foot house. Let's assume 8-foot ceilings. So that's 16,000 cubic feet, 2,000 times 8. That works out to 1,185 pounds of air. If we wanted to raise the humidity from 12% to 50%, you need to add 52 grains of moisture per pound of air. That's just off the psych chart. So you take the pounds of air, 1185 times 52, you get 61,620 grains. What's a grain? Well, there's 7,000 grains of moisture per pound or pint. Pint of water is the same as a pound. So we have to add 8.8 pints. But the house isn't a Tupperware container. It's got some air changes. In this case, we're going to assume half an air change. So 4.4 pints per hour. So what we have to add each and every hour, multiplied by 24, 105 pints per day, 8 pints in a gallon, 13.2 gallons per day is what this house needs to go from 12% to 50%. And that's once it's in a steady state. When you first start out, everything in the house is going to be dry, so you have to add moisture in to compensate for that. It has to catch up. But once it's in a steady state, that's what you would be needing to add every single day. That's the calculations, but we've done it for you. So there's this table. So this table's in many, many brochures and spec sheets and everything else. Table is simply taking all those calculations and putting into a table form. So let's go back to our example. 2,000 square feet, assuming 8-foot ceilings. Whenever you see a chart like this, AHRI uses square feet, and they always assume 8-foot ceilings. So you could calculate the cubic feet if you had 10-foot ceilings or 12-foot ceilings or cathedral ceilings and just use the same table, but use cubic feet instead of square feet in ceiling height. So 2,000 square feet, 8-foot ceilings, half an air change per hour is tight. You can see the calculations right there. Same thing, same idea. We know we've got a lot of models, and so we created a table to help you narrow down which models to pick. If you already know what models you put in, obviously you don't need any assistance from us. But if you're new to humidifiers, this is a way to drill down and just know which models to talk about. Because it covers the whole country and it covers lots of different HVAC types, it can be confusing. I just want to give you a couple examples to show. So first off, all you have to do is figure out what column you're in. Midwest, Northeast, Mid-Atlantic, Mid-Southern, etc. So we're in Wisconsin, we're in the Midwest, so we're in that first column, Midwest, Northeast. Most of our HVAC systems are single-stage fossil fuel furnaces, so we're right in that first section there. Gas/oil furnace, single-stage or multi-stage. And no surprise, we have very cold winters. Single-stage furnaces are going to provide lots of heat, and they're going to run plenty. So any of our humidifiers is going to work just fine. The HVAC system type below it, fossil fuel modulating, this is a true variable speed system. So very uncommon. You know, this is the high-end system. But some of the advantages are obviously it's going to have a variable CFM and a variable BTU output. And so because of that, remember, water, airflow, heat are the three things we need. Sometimes we may not have a lot of airflow and we may not have a lot of BTUs available. So we get rid of our bypass units because of the airflow issue, and we pick larger capacity units because of the lack of BTUs. So a power humidifier or a steam humidifier. And that's just kind of how we go through each type of HVAC system. So you can kind of drill down to figure out what system makes the most sense in your region of the country and for what HVAC system you're looking to put it on. I would say if this is confusing, if you have any questions, this is a great opportunity to utilize our world-leading, we have excellent tech support. Call our tech support group up. They'll be more than happy to ask you a couple questions and help you figure out which evaporative humidifier types make the most sense for you. Give you a couple options. So let's take a look at some of the different options. We're just talking evaporative humidifiers today, and so you can see we have model 400, which is a recirculating or water conserving humidifier, the model 500, which is our small bypass, the model 600 is a large bypass, and the model 700 is our fan powered unit. That first chart is showing the amount of humidity you're going to get assuming 120 degree plenum temperature. You can see 17 gallons per day, 12 gallons per day, 17 gallons per day, 18 gallons per day. Next to that, you see that some of our competition uses 140 degrees at the assumption, and we think that that is not your typical furnace temperature. We think most furnaces are not that hot. And why does that matter? Going back to water, airflow, and heat, if you assume 140 degrees, you're going to think that you're going to get more evaporation out of an evaporative humidifier, whether it's ours or anybody else's. More BTUs, more evaporation. And so we think that's not doing you a favor because you might undersize the humidifier in the real world. So we're assuming a lower plenum temperature to give you a conservative estimate so you pick a humidifier that we all know is going to work well. And so that far right column, you can see the square footage that those humidifiers can handle, assuming 8-foot ceilings, assume a tightly constructed home. And then you see below that same chart again, just summarized so you can compare the two. So in our example, 2,000 square feet, 8-foot ceilings tightly constructed, you can see any of the humidifiers would be able to properly humidify that home. Let's go through how a typical bypass humidifier works. So Humidistat's going to call for humidity. So the solenoid valve clicks open, delivering water to the top of the inside of the humidifier. That water then travels across the water distribution tray and runs down the water panel, fully wetting the water panel. Of course, while this is happening, either the furnace or just the blower is running, so we're moving air through the humidifier. We evaporate some of that water, turns into a gas, and then it travels back into the HVAC system through the bypass duct so that humidified air can then be mixed and then distributed throughout the home. Here's our model 600. This is our large bypass humidifier. The 600 comes with an automatic humidistat. The 600M comes with a manual humidistat. And we'll talk about that later, but I would strongly encourage you to consider the automatic humidistat. We'll talk about why in a little bit. The nice thing about the large bypass humidifier is that the only moving part is the water solenoid valve. It uses the pressure differential created by the HVAC blower to move air through the humidifier to evaporate the water and then reintroduce that humidified air back into the HVAC system. We recommend strongly supplying all of our flow-through humidifiers with hot water. And there you see some more detail. Below it you see pictured the automatic humidistat, the manual humidistat, and then the number 35 water panel that goes inside of it. Next we have just the smaller version of that, the model 500 or 500M, our small bypass. Same exact mechanical processes, simply a smaller footprint, therefore a smaller water panel, so less output, lower evaporative capacity. Same options in terms of automatic humidistat and manual humidistat, but the smaller water panel is a number 10, and you can see the smaller footprint there. The 400 is still a bypass evaporative humidifier, but it's not a flow-through. You would expect no water to ever come out of the unit, and it does that by having those floats you can see there on the far right exploded view drawing. And then there's the dimension showing the automatic humidistat, manual humidistat, and number 45 water panel. Here's our 700, the fan-powered humidifier. It uses a fan to help the air being moved by the HVAC blower to go through the water panel. So we don't have a bypass duct, we don't have the pressure differential created by the HVAC blower. We're using the fan to help pull that air through the water panel. So humidistat calls for humidity, water valve opens, and the fan turns on inside the Model 700. Water runs down the water panel. Air moves through the water panel, evaporating some of the water. That water hits the back of the 700 and then has nowhere to go but to circulate back into the HVAC duct through those 4 side openings that you see there indicated by the arrows. That humidified air then gets mixed with all the air being moved by the HVAC system and dispersed throughout the ductwork. Model 700 has a slightly larger evaporative capacity, not a lot though, don't overstate that. So you can, instead of 17 gallons per day, you can get about 18 gallons per day out of it. So a slightly bigger home. And there you can see the dimensions, Model 60, manual humidistat, and then the number 35 water panel. There's 2 humidifiers I want to cover. We've got our non-ducted evaporative humidifiers, the Model 350 and the Model 360. Start with the Model 350. You're going to run hot water to this, a drain line to it, plug it in, and it only comes with the manual humidistat. This is typically going to be snug between the floor joists in a basement. Then you're going to run a duct coming out the back there, you can see, to go up into the occupied part of the house, typically through a closet, and then you're going to cut a register in that floor above for that humidified air to exit into a large space like a hallway and then mix thoroughly with the rest of the air in the house. This is obviously a great option if you have radiant heat and maybe mini splits, or radiant heat and window air conditioner, so there's no forced air ductwork at all in the house. It's also popular for humidors, for example. 360, same concept. You're going to run hot water to it, plug it in, run a drain line to it, but this is a through-the-wall unit. So you might pick, say, a bathroom closet, because bathrooms are a great place to get hot water to, power to, and a drain line to. And then on the other side of that closet, you would want that to share a wall with, again, a large open area, like a hallway. air gets pulled in, humidified, and then pushed out that grill you see on the right, and then that air mixes and disperses throughout the house. Let's talk about our controls, the humidistats. So you see pictured there, we've got our Model 60 automatic humidistat. You can see the digital display, the LEDs. We'll talk about that in a little bit. And then on the far right, you have our mechanical humidistat. In between, you have one of our IAQ thermostats. This happens to be an IAQ thermostat that also has Wi-Fi. It's our Model 8920W full color display. But we offer several different versions of thermostats that also have the IAQ function, so they can control the humidifier. We also have the option of Wi-Fi or no Wi-Fi. That's a great option. If you think about if you have your HVAC system and your humidifier and maybe some other IAQ products controlled by a Wi-Fi IAQ thermostat, now you can view not just your HVAC system, but you can also view your IAQ products. So for a humidifier, you can see what the relative humidity in the home is. You can see if it's running. You can make adjustments to the set point if you wanted to. If you set up service reminders, you would also see that it was time to replace the water panel. You can also set up alerts through the Wi-Fi thermostat. So you would receive an email alert saying home is too humid or home is too dry. It's a great option if you have let's say a vacation home where you're controlling the heating, cooling, and IAQ in that other home or other building. We're talking about a humidifier. So in most parts of the country, we're talking about raising the humidity during the heating season. However, in the desert Southwest, we're going to humidify year-round, and in areas that have at a high elevation, like Denver, we would be humidifying for much of the year. Typically, we want to raise the humidity as high as we can without getting damaging condensation. So, if we can maintain 35% in the heating season, that's excellent. You're going to get the benefits of adding humidity to the home, fewer colds, no nosebleeds, no static shocks. Your wood floors aren't going to contract too much. Your cabinets are going to be in good shape. If you have wood frame doors and windows, those aren't going to shrink and get leakier, et cetera, et cetera, et cetera. If it's mild out or your home can hold more humidity, you might be able to achieve 40% or even 45%. Again, the goal is get the humidity as high as we can, but you have to remember, we don't want to have damaging condensation on the windows. If you've got water pouring down the windows, you don't want to raise the humidity. The house has already got too much humidity into it. If you add another pint of water, it's just going to wind up condensing on the windows. And here's the thing, if you take nothing else home today, if you see water pouring down your windows, I don't mean a fog like you get when you cook spaghetti, but water beating up and pouring down the windows, that's bad. But there's also a chance that that could be happening somewhere in your exterior walls. Somewhere between the siding and the drywall, you may have hit dew point. So you can see the water on the windows. That's an indication that your relative humidity is too high, regardless of what the RH is. If it's 20 below zero, you're not going to be able to hold 35% in your house. That's one of the advantages of the automatic humidistat. So let's talk about that. If the goal during the heating season is to raise the humidity up as high as we can without getting damaging condensation, what we're really saying is we want to be able to track the RH set point to the outdoor temperature. And if we use the automatic humidistat, it comes with an outdoor temperature sensor. So it knows what the outside temperature is. So what does that mean to you? It means overnight, as it gets colder and colder and colder, the automatic humidistat is automatically going to lower the RH set point without you having to do anything. The following morning, as it gets milder and milder outside, the humidistat will automatically raise the RH set point. So you get the benefits of being able to hold a little bit more humidity in the home. It's a huge advantage. If you think about a manual humidistat, now the consumer, the occupant of the home, is the thing that has to know what the outside temperature is, and they're the thing that has to go adjust the manual humidistat. But we know they're not going to do that. They maybe if we're lucky, they do it once per day. Usually what their guidance is going to be, they see damaging condensation on the windows, so they lower the humidistat, but they never raise it back up. So they're not getting as much of a benefit as they could be. So really consider the advantage to the consumer of the automatic humidistat. And of course, you can charge more for that humidifier. The benefits certainly justify the extra cost of going from a manual to an automatic humidistat. Our tech support group would be happy to discuss that with you. We have brochures, we have sales videos that will walk you through those benefits. And of course, as always, reach out to your AprilAire district sales manager, and they'll be happy to come in and do a training class, either to your sales group or to your management group or to your installers. We can tailor that training to whatever their audience is. If in a given application you want the automatic humidistat, let's say for the digital display, you want the automatic humidistat for the indicators, change water panel, call dealer for service, there's an error code, and then you want the feature of the blower activation, which we'll talk about later, but you don't want to run the outside temperature sensor for whatever reason. Either you can't, or aesthetically, the occupant doesn't want you to. You can run the manual humidistat in manual mode. The installation is very, very simple. The unit's going to install on the return duct, not in the living space, in the return duct, not in the living space, on the return duct. That's going to let it measure the relative humidity and temperature of the air coming from everywhere in the house that has a return. So it's a good representative sample. You're going to drill a hole in the duct so the relative humidity sensor on the back will protrude into the ductwork. There's a little dome on the back that protrudes into the ductwork with a seal that seals up that hole, so you're not going to get any air pulled in. And then you just secure it with sheet metal screws. The terminals inside are very straightforward. It's a very simple installation. We'll go through it, but you can see you've got your basic HVAC terminals, RCW, there's a couple G's in there that we'll talk about, a place to wire the outside temperature sensor, and then your HH terminals. That's how you're going to tell the humidifier to run. Obviously, that's pretty important. The AB terminals we're not even using. In fact, we're going to start offering humidistats in the near future that don't even contain those AB terminals. The humidistat outputs a dry contact, and all of our evaporative humidifiers require 24 volts to run. So you'd use the field supplied transformer, the 24 volt 10 VA transformer, to supply the 24 volts. So you can just wire that 24 volt transformer into the 120 volts anywhere inside the HVAC system before it goes into the circuit board or before it goes into the blower, of course. So usually there's a convenience switch, a junction box on the outside of the HVAC system. You can just knock out one of those slugs and install it through that access hole in the junction box. Here's our outdoor temperature sensor. You can see it's just a white sensor with a bracket on the end. It includes a run of wire. Typically, you're going to have to extend that wire, of course, to get it outside, depending on how far run it has to be. We just want to make sure that that's reading an accurate outside temperature. So we don't want it in direct sunlight, any side of the house but the south side of the house, because the south side of your house gets the most sunlight, and then away from dryer vents or anything like that. And of course, for most of the country, you want to mount it high enough that it's not going to be buried in a snowbank. That's it. Because the key to the automatic humidistat is it measuring the correct outside temperature, it's always worth, before you wire the outside temperature sensor to the thermostat, it's always a great idea to grab your multimeter and just ohm it out. So, grab your smartphone, see what the outside temperature is for this zip code, ohm it out. This table is in the installation instructions, and you can see, for example, let's say it's 20 degrees outside, you'd want to see about 45,000, 46,000, 47,000 ohms. Again, if we're plus or minus 5 degrees, that's perfect. That's perfect. Let's go through the wiring. The key here is I want you to understand that this wiring is very straightforward. There's not a lot going on here at all. So what we've got in this picture is, starting at the left, you've got your thermostat, you've got your furnace. So those are already going to be wired up, of course. R to R, G to G, Y to Y, W to W. Maybe you've got a C terminal on your thermostat, maybe not. That's why it's dashed. Anyway, so that's already existing. Then at the top of this diagram, the 12 o'clock position, you can see there are the screw head terminals inside of our automatic humidistat. And then you've got the humidifier itself. In this case, it's a bypass humidifier with the solenoid valve and the 2 yellow wires coming off of it. And at the very bottom of the diagram, you can see where the 24-volt transformer would wire in. So let's just go through it. This is very, very straightforward. Let's start at the left. Starting at the automatic humidistat, so starting at the top of the diagram, you can see we've got power, R and C. That's just going to go to R and C inside the HVAC system. In this diagram, inside the furnace. So you're just going to piggyback another wire to R and another wire to C on the furnace. Okay, let's go back up to the automatic humidistat. Let's skip a few terminals and let's go under inputs. You see W. We're just going to add another wire and piggyback that W at the humidistat to W down at the furnace. So we've just grabbed maybe 3 conductor wire, whatever you have handy, and we've piggybacked in an R and a C and a W. Very simple, very straightforward. So far, it's just like wiring up another thermostat, really. Let's go back up to the humidistat. A and B we can skip. Don't have to worry about those. 2 terminals in the middle. That's where you're going to wire the outdoor temperature sensor to. So the outdoor temperature sensor has 2 conductor wire. It's no polarity. So 1 wire, 1 conductor goes to each of the 2 ODT terminals. 2 wires, 2 screw heads. Couldn't be simpler. Heck, we're almost done. Let's skip the G's for a second. We'll come back to those. Let's look at the H's. On the output section, you've got 2 H's. Remember, this is providing a dry contact when the humidistat wants the humidifier to run, and our evaporative humidifiers needs 24 volts to run. So all we need to do is create a big series circuit that's going to be composed of the 2 H terminals, the 2 yellow wires on the solenoid valve, and then the 2 screw head terminals on your 24-volt transformer. So again, just a large series circuit. So in this diagram, we're coming out of one of the H's, we're going to one of the yellow wires on the humidifier, coming out of the other yellow wire on the humidifier, going into one side of the 24 volts of the transformer, and then the remaining screw head terminal on the transformer, we're running back up to the last H terminal. So that's simple, straightforward. And that just leaves 2 terminals. At the humidistat, you've got a G as an input and a GF as an output. Let's follow those wires back. Let's start with the G at the humidistat. So G up top, let's follow that wire down, and you can see that that goes to the thermostat. So what are we doing? Well, look at the G between the thermostat and the furnace. That's disconnected. So that's the only change we've made so far. So at the HVAC system, you've got a G coming down from the thermostat or up from the thermostat, over from the thermostat. Disconnect that, hopefully green wire, and we're going to extend that green wire to G on the humidistat. So you probably have to add a wire nut and add a wire to get from that G that was landed at the furnace. Now we're just going to land it at the G on the humidistat. Then at the humidistat, you see we got a GF. We're going to add a wire, include another wire, and that's going to go from GF at the furnace, F is for furnace, GF to G on the furnace, and that's it. So all you've done, basically, is create a G circuit from the thermostat to the humidistat, from the humidistat to the furnace. That's it, you're done. Internally, we call that breaking the G. But the concept is that lets the humidistat know when the thermostat calls for fan. When the thermostat calls for fan, the humidistat knows it, and it can tell the humidifier to run. And then, of course, it can pass that fan call back to the furnace so the blower actually runs. But it also lets the humidistat make a fan call. That's the key to this. It lets the humidistat make a fan call. So we can get lots more run time than just having to wait for the thermostat to call for fan or the thermostat to call for heat. And that last feature allows us to utilize our blower activation. So you see at the bottom there, there's a switch. It says blower activation, off and on. We highly recommend installing our 700, 600, and 500, all of the flow-through evaporative units, to hot water. Plumb them to hot water. That means that they'll get good evaporation during a heat call, because you'll have hot air and hot water, but it also lets you get good evaporation during just a fan call, where you have room temperature air and hot water. Remember, water, airflow, and heat. Blower activation really gives you the ability to achieve as much humidity runtime as you can. So you're going to get as much benefit from the humidifier as you can. In the on position, the humidistat, of course, will run the humidifier whenever the house is too dry and the fan's running or the furnace is running. But it gives it the ability to also on its own make a fan call to give you additional runtime. We talked earlier about the main advantage of the automatic humidistat is the outside temperature sensor. The outside temperature sensor is what makes it an automatic humidistat, because it can automatically adjust its RH set point. If you choose not to use the outdoor temperature sensor, you can still use the Model 60, but you would run it in manual mode. So if you're not using the outside temperature sensor, you can run the Model 60 in manual mode. This has nothing to do with blower activation. Just slide that little switch on the inside now. On the inside, there's a little switch labeled auto and man. Just push that little switch over to the manual position. What that does is it tells the humidistat that it's always 20 degrees. So you don't need the outside temperature sensor. And then inside the carton that the Model 60 came in, there's a little sticker that you would apply to the humidistat that covers up the off 1, 2, 3, 4, 5, 6, 7 numbers and replaces it with a scale so that the consumer can adjust that knob to match up with what the outside temperature is. So you get the lowering of the RH when it's very cold outside and the increase in the RH set point when it's more mild outside. Another advantage of the automatic humidistat, besides the automatic humidity adjustment and the blower activation option, is that you have diagnostic LEDs, or status LEDs, let's call them. You can see there's 3 LEDs. Green at the bottom tells you when the humidifier is on. Yellow in the middle tells you change water panel. And then red at the top tells you if there's a problem. You see call dealer for service. And when the red LED for call dealer for service lights up, the display changes to an error code. So it's obvious that there's something going on. You can see an E1, an E2, an E3, or an E4. E1 is the unit is saying there's a problem with the relative humidity sensor. What do? Turn the dial to test/reset. And you can tell the consumer right over the phone to do this. Turn the knob to test/reset. After a couple seconds, It'll reset that error code, have them turn it back to whatever number it was set to previously, and see if the error code goes away. If it does, then it was just a power surge or a brownout or something like that. Just like rebooting your computer or rebooting your Roku box, rebooting your Wi-Fi router, something you'd have to do on a regular basis. Doesn't mean the humidistat's bad, because you're going to turn it to test/reset and see if the error code goes away. If it comes back, then of course replace the humidistat. E2, same idea. The internal diagnostics have said there's a problem with the control knob. So have the consumer turn the knob to test/reset. If the error code goes away, then we're fine. If it doesn't, then replace the humidistat. E3, it's not getting a good resistance from the outside temperature sensor. Now I'll tell you right now, outside temperature sensors really don't go bad. So what this really is almost always a loose wire. Either a loose wire at the humidistat or a loose wire at the wire nut that you used when you increased the run length on the outdoor temperature sensor. Rarely is the outside temperature sensor bad. So before you replace the outside temperature sensor, replace the humidistat, you're always going to turn that knob to test/reset and see if the error code goes away. In the case of an outside temperature sensor, I would just ohm it out. See if you're getting a short or see if you're getting an open circuit. That'll tell you if maybe you've got a nick in the wire and the bare leads are touching, or you've got a loose wire. Easy to fix, pretty straightforward. E4, you're probably never going to see that. That's only on an older communicating thermostat that we don't offer anymore. If you are seeing an E4, a lot of times what I've seen is contractors have chosen for some reason to jumper something out. They've jumpered out the A-B terminals for some reason, and they're of course confusing the humidistat. So don't jumper anything out, just follow the wiring diagram and you should be good to go. Test/reset, the reset function, turning it to that test/reset, that also resets the change water panel light, for example. Another really nice advantage of the automatic humidistat is the test mode. Test mode allows you, regardless of the relative humidity in the home, to run the humidifier for 1 minute. Test mode lets you run the humidifier for 60 seconds. So, turn the blower activation switch to off. That way we're testing the wiring between the HVAC system and the humidistat. Kick the power back on. I would say just make a heat call. Keep your life simple. Just make a heat call. Wait until you feel warm air coming out of the supply registers. Then go to the humidistat and turn it to test mode. Remember, test mode's only good for a minute. So if you turn it to test mode and then you walk over to the thermostat and you make a heat call, by the time you get back to the humidistat, your minute's already expired. So heat call first, test mode second. When you turn it to test mode, you'll hear a click at the humidistat. Shouldn't see any error codes, and you should hear a click as the solenoid valve opens up on the humidifier. If that happens, the wiring's good, then just check to make sure you got water going through the humidifier, then you know your plumbing's good, and you know that you're going to be good once you get into the heating season. So turn the dial from test mode back to whatever number you want to set it to. If you leave it in test mode, remember, test mode's only good for 1 minute. Test mode's only good for 60 seconds. If you leave it in test mode, at the end of test mode, the solenoid valve is going to close and it's never going to run again. Right now, our poor tech support guys are getting inundated with phone calls from consumers and contractors that are saying the humidifier is not running and the humidistat's showing us an R1 or an R2 or an R3. That R with a number after it is just the revision number. The display changes to the revision number and it flashes the lights to try and indicate to you, hey, you've left this in test mode for too long. So at the end of 60 seconds, you got to take it out of test mode because it'll never run again. If you see it displaying R1, that means you left it in test mode too long. Turn it back to whatever number you want to have it at. If you choose to, instead of installing one of our automatic humidistats, if you order a model 600M or a 700M, 500M, 400M, the M indicates that humidifier is bundled with a mechanical humidistat. So mechanical humidistat, see it pictured there. Mechanical humidistat, obviously the consumer is going to have to make adjustments to the RH set point based on temperature. Also, the installation becomes a little bit more challenging because there's no smarts built into the humidistat. It's mechanical. It calls for humidity when the house is too dry. So now you're going to have to see what accessory terminals are available in your HVAC system in order to prevent the humidifier from running unless you've got a fan call or a heat call. So you're going to have to look and see, do I have EAC terminals, which are typically energized with a blower call? Some manufacturers make those 24 volts, some manufacturers make them 120. So if they're 120, you have to step them down with the included transformer 24 volts. Or do you have hum terminals? Hum terminals are typically energized with just a heat call. Are they 24 volts or 120? If they're 120, you got to step them down with the transformer. So every installation is potentially different. That takes more time. You don't get the digital readout. You don't get the automatic adjustment. You don't get the simple, consistent, every job has the same wiring. You don't get the blower activation. You don't get the digital display of the RH. You don't get the indicator that it's time to change the water panel. And you don't get the easy troubleshooting option of the error codes being displayed. So I think that automatic humidification has a lot of advantages over the manual humidistat. I think it makes a lot of sense for something for you to consider switching to if you don't already. And as always, our tech support group is happy to answer any questions you have, or your AprilAire district sales manager would be happy to do a training class or just talk to you about the advantages. An even better option than the automatic humidistat is going with one of our Wi-Fi IAQ thermostats. Consumers love the ability to view and make changes to not just the furnace and air conditioner, but also their IAQ products. We call it confirmation and control. It's really a feature they seem to like, especially with lots of buzz about smart homes or connected homes. This is a part of a lot of people's smart home setup. Just want to give you some general recommendations. There is an evaporative capacity check. This is if you're stumped on troubleshooting, always call tech support when you're on site. We'll be happy to help you. But this is something that you can do as well. What this will do is this will confirm if the humidifier is evaporating the amount of water it's supposed to. So if the humidifier is evaporating the amount of water it's supposed to, the issue must be with something external to the humidifier. The way it's installed doesn't let the humidifier run enough. The house is looser than you thought because they've got a fireplace flue that's open. That's a very common thing. Real fireplaces, not inserts, but real fireplaces, you have to have that flue closed. Even closing the flue, sometimes that seal is worn out and you really expose yourself to the stack effect where you get that warm air rising and carrying the humidity out of the house. And of course that depressurizes the house and pulls that cold air right in as fast as it can. But the evaporative capacity check is very straightforward. The key to it is you got to take good measurements. Garbage in is garbage out when it comes to calculations. So we're going to make a heat call at the thermostat. We're going to make sure that that runs for at least 5 minutes. So we've got good hot air. We've got the humidifier running, so that good hot air going through the humidifier. Water panel is good and soaked. Then we're going to take a measurement. What are we going to do? We're going to fill a quart jar from the drain line. And we're going to time how long it takes. We're going to time how many seconds it takes. You're going to keep track of what the fill line is on the quart jar and how many seconds it takes to fill it. Jot that down. Empty the quart jar. Repeat the process. Then you're going to take the cover off the humidifier You're going to disconnect the feed tube and have the feed tube run into the quart jar. As soon as that first drop of water goes into the quart jar, you're going to start the timing. You're going to time how long it takes to fill the quart jar from the feed tube. Jot down that time. If you think it through, you'll see that it should take longer to fill the quart jar from the drain line because we should have been evaporating some water, so there's less water available. If you call us up with those two times, we can tell you how much water you're evaporating, but because quart jars are certainly not calibrated devices and you can be off by a few seconds, use the general guideline that we show you there. You can always give us a call and we can help you out. Here are some general good rules to follow, and I'm going to give you a little bit of context for each one because I think that some of these are a little bit overstated, let's say. So the first one, always use the Model 700, which is our power humidifier, so no bypass. If you have a zone system or with a true modulating variable speed system, so a true variable speed system where it's ramping up and ramping down, so you could have very, very low airflow sometimes. The power humidifier, the Model 700, is very forgiving to changes in airflow, and that's inherent to a true variable speed HVAC system, and that's inherent to a zone system with motorized dampers in the ductwork. Our three flow-through evaporative humidifiers, the 500, 600, and 700, and of course the 500M, 600M, and 700M, we always want to plumb those to hot water. That hot water will always give us more evaporation when there's a heat call, and it even gives us the ability to evaporate when just the HVAC blower is running. That's important. The Model 400, because it has those small reservoirs inside, it's not a flow-through unit, so the hot water doesn't really give you any benefit. So typically you plumb that to cold water. Because the water sitting in those reservoirs is going to have time to cool off to room temperature. That's why. So it's really only going to give you good evaporation during an actual heat call. You can't oversize the humidifier because it's always going to be turned off by the Humidistat. So if you're not sure how tight the house is, upsize. When you're looking to cut your opening into the ductwork, if you're going to install it on the supply, make sure that you're not installing it on the blanked off A-coil side. So if you can see the fins and tubes, that's awesome. If you can see the blanked off side of the A-coil, you're not going to get good airflow. The Model 60 always goes on the return. Always goes on the return, never up in the living space, never on the supply duct. And we strongly encourage you to supply the flow-through humidifiers with hot water and therefore put the Model 60 into blower activation on position. Bypass humidifiers work exactly the same, whether the bypass humidifier itself is on the supply and the bypass duct goes to the return, or the opposite is true. The bypass humidifier goes on the return and the duct goes over to the supply. No difference. Same airflow, same air temperature. Water, airflow, heat, you're going to get the same amount of evaporation. I really think it's worth purchasing genuine AprilAire water panels. And it's not just because that's how we make our money. It's not, honestly. We've been making water panels for coming up on 60, 70 years now. We know that our aluminum mesh water panels are going to hold up to a season's worth of use. The clay coating is not going to wash off. The water panel is not going to start to slump. A lot of knockoff water panels will slump over time. That can cause two very different problems. One is if they slump at the top, you can get a gap that allows air to whoosh over the top of the water panel. That can blow water off of the water panel. That's entrainment. You can get water damage, corrosion, mold growth, all kinds of stuff. If the water panel slumps at the bottom, it can plug the drain. Just saw that happen. Consumer was using a knockoff water panel they bought at the hardware store. It slumped, it plugged up the drain. drain backed up. The AprilAire water panels are not going to do that. You change them out every season, they're going to hold up. They're going to get good evaporation. They're going to get the right amount of wetting. They're going to let the right amount of air travel through them. And this last one here, never use a model 400 heat pump. I think that's grossly overstated. Lots of people put 400s on heat pumps, but you have to remember water airflow heat. Heat pumps are going to have a lower plenum temperature. They're going to output about 90 degrees. So that's not as hot as a fossil fuel furnace, so you have fewer BTUs available on the air temperature side. And as I mentioned previously, there's minimal benefit to plumbing the 400 with hot water because you have those small reservoirs that are going to fill, and that's going to allow that water to typically cool to room temperature. So you don't get BTUs from the air, you don't get BTUs from the water, you're going to get a lot less evaporation. And so we just don't want consumers to experience lack of humidity. Now there's lots of heat pumps out there that run enough, right? Heat pumps usually run longer, so you get longer run times, and so the duration of the calls for humidity make up for the lack of evaporation over every minute it runs. So you wind up with enough gallons per day to properly raise the humidity of the house. We offer maintenance kits. It's the easiest way to maintain the humidifier. I'm a big fan of if it ain't broke, don't fix it. I did tech support for a lot of years, and I've seen guys take apart the solenoid valve, lose the orifice, then they've got way too much water going through the unit. I've seen guys try and clean out the orifice, end up reaming it out, and they get way too much water going through it. That orifice has a tiny, tiny hole. It's like a, depending on what color orifice it is, it's like a number 73 or number 77 drill bit. It's a tiny, tiny hole. 3 gallons per hour or 6 gallons per hour. Easy to ream that out and get way too much water going through it. I've seen guys try and clean out that strainer that keeps debris from entering the solenoid valve, end up tearing holes in it. They're trying to do a good thing and they wind up just letting debris from the water heater get into the solenoid valve and plug it up. If you're not having a problem, the maintenance I would do is follow the water flow path. Take the scale control insert and the distribution tray out. Make sure that you don't see any accumulated mineral deposits that are plugging it up. Make sure nothing's cracked. Take the water panel out, throw it away, put a new one in. Make sure the drain is open. The drain line has a continuous downward slope and it's not getting microbial growth in it. And you should be good to go for the next season. We offer a maintenance kit for each model, includes everything you see there, all the parts and pieces, even a replacement owner's manual. If you're finding that the bypass humidifier has too big of a footprint for the short side of the ductwork that you're stuck putting it on, you can't get it on the wide side of the return, you're stuck on the short side, we do offer 2 adapters that allow you to install the bypass humidifiers onto a smaller duct. Contact tech support or your AprilAire district sales manager. They can get you some of those. Thank you very much for your time. We started including this slide in all of our PowerPoints because we think it's important that you guys understand how much we appreciate your business. Not just the sales department, but also our really, really great people in our manufacturing department. Our manufacturing is all done in Poynette, Wisconsin, just a little bit north of Madison. It's a great group of people. They're what make the products that allow us to all be in business. So thank you very much for your business, and I thank you for your time today. Enjoy the rest of your day. Thank you very much. I will leave the GoToWebinar tool open for a couple minutes so you can submit any last-minute questions you have, and I will do my best to answer those as quickly as I can. So thank you very much. Enjoy the rest of your day.